All right, everyone. So let's get back to it. Again, lesson 16. Lesson 16, we are adding areas. Adding areas. So let's kind of get those math brains woken up just a bit. So we've been learning all about this whole concept of area, what it is, what it isn't, right? So what it is that space inside a two-dimensional closed figure, and we measure it in square units. When we model it, we have to make certain that our square units aren't overlapping or heading out of the boundary of the two-dimensional figure, right? We always express the solution in square units. If the unit of measurement is identified, we use it, okay? Then we talked about different types of models. We figured out that those tiled models do look like arrays that we would build in multiplication. You were introduced to the formula area equals length times the width. Lots of models were displayed. Learning how to fill in that formula was modeled for you as well, with that emphasis on expressing the solution in a square unit. Then we came into lesson 16 that introduced this concept of adding areas, taking one part of a shape and another part of a shape and adding those areas together. And we quickly saw that that required multiple steps and two different operations. One being, of course, multiplication through the concept of area, and then addition, adding one area to another. And then we took it to the next level about how we could take a look at the length and the width of a two-dimensional shape by kind of pushing the pieces together and looking at it as one shape instead of two. We're going to keep going with that today. You can see on page 345, there is a closed two-dimensional shape on the top of this page, and it is in two separate colors, and there's a reason for that. And we're going to be discussing that right now. I'm going to be modeling this for you. So please make sure it's in front of you. I am going to share my screen and we're going to talk about this. So please take some notes. All right, so what you are seeing in front of you right now on your device is page 345 in your book. Let us take a closer look at it. So it is asking you here up above to study the example showing how to find the area of what we call a combined or a composite rectangle. And then it's asking us to solve a few problems. We've got this, we can do it, friends. Here's the example. The diagram shows how Miss Rigby covers her bulletin board, like, of course, like what's behind me, with colored paper. What is the area of the whole bulletin board? So again, friends, going back to those close reading skills, my question is about the area of the whole bulletin board. Not part of it, all of it. Okay? So it says that you can count the square units. You can count it, and you can see here that there are 32 total square units, right? Or you can multiply the length and the width. So friends, please draw your attention to here, right here. You can see that the pinkish red section is 2 feet long. You can see that this light bluish section is 6 feet long. But you can take the entire length of both of these parts and express it as 8 total feet. Okay? This is where the 8 comes from. It is 2 plus 6 equals 8. And the width, of course, is 4 feet. So if area equals length times the width, we have 8 feet in total length, 4 feet in total width, and it is 32 square feet. Again, friends, look that we are using feet and not units here because we are being given the unit of measurement. Please express your solution with that unit of measurement. All right? Let us take a look at number 1 here in the green. And it says to write an equation for the area of each colored section of the bulletin board. I'm going to read that again. Write an equation for the area of each colored section of the bulletin board. An equation for the area of each colored section. You will notice that I have underlined it, I have close read it. Very important that you understand what I am asking you. We're going to take this red section first. All right? This pinkish red section right up here. So you can see that the red section has this length of 2 feet, and it has a width of 4 feet. So you can see that the total area of this section here is going to be 8 feet squared, or 8 square feet. Okay? And you can see that this blue section here has a length of 6 feet, a width of 4 feet. And so the total area of this blue section here is going to be 24 feet squared, or 24 square feet. Also pay special attention to this word here. I am asking you for an equation. I am asking you for an equation. Equations include, of course, an equal sign. All right? Now, if we take a look at number 2, it is asking us to add the areas of the 2 sections. How does this area compare to the answer in the example? So if we take our 24 square feet and our 8 square feet, we are going to end up with 32 square feet total. So I've added the area of the 2 sections. Great. I've answered the first question. I'm not done. I'm not done, friends. You were asked another question. How does this area compare to the answer in the example, which is here? Friends, the answers are the same. The answers are the same. I have answered both of my questions. That reminds my brain that I have. All right, let's take a look at question number 3. And it is saying Baxter's Dog Run, over here, has a small covered section and a large open section. What is the total area of the dog run? the total area of the dog run. Now, friends, there are one of two ways you could do this. There are one of two ways. You could take each section and you could find the area of each section, or you could do it together. So let's take a look. In the first way, we could have the small run or the covered section, right? We could do that one first. So we could say 3 times 4 equals 12.
Oh, you mean my count? Okay,
Your mic stay muted, friends. Thank you. So you have 3 times 4, and that equals 12. And we're going to call this meters squared. And then we have over here 6 and 4. Equals 24 meters squared. Where did I get the 6 times 4? 6 in length, 4 in width. That's the open section. 6 in length, 4 in width. And then I simply add them together. And that total is going to give me 36 meters squared, or 36 square meters, when I take each part. Again, the covered section, the open section. Or what I could do is simply do it all together, taking the entire length into consideration. I could simply say 9 meters long and 4 meters wide equals 36 meters squared. And you will notice that these two answers are, of course, the same. 2 different ways to look at it, 2 different ways to model and break it apart. The answers are the same. Could you challenge yourself and do it both ways to check your own work? You absolutely could. You could break it apart. You could solve it as one length and check to see that they're the same. If they're the same, you've done it correctly. If they are not, you need to check your work. All right? This is adding areas, my friends.